Hello friends, welcome back. In the previous video, we have seen about implementation of logistic regression where we had imported libraries and we had loaded iris dataset where we had two classes, right? Setosa and versicolor were the two classes we had there. Though we had three classes, we had used only two. Then we did train. So how did I split my data set into 70-30, right? That was training set के लिए 30%, sorry, 70% of the data and 30% for my test cases, right? So then I had used logistic regression, right? So then we were able to draw the line, then try to segregate the both the classes. Then we were able to plot them and show. In this video, we would like to continue the same thing, but instead of training the model with logistic regression, we will be using the SVM. All right. What is SVM? Support vector machine. So in this video, we will try covering implementation of support vector machines. Right. So now, what would be the first step? As usual, so we will be importing the libraries. Okay. So very similar to that of logistic regression. In the logistic regression, we have seen like NumPy, Matplotlib. Okay. Then sklearn along with the data sets. Right. Then sklearn model for splitting the data into training and testing. And then we had imported logistic regression. Here, instead of logistic regression, we will be importing support vector. And support vector in this library is called as SVC and support vector classifier. And then we will be importing the performance metrics wala, that is classification report, right? So we will be importing all these things. Let's write that. First is NumPy, then matplotlib, sklearn, then we are splitting के लिए we are importing, then support vector classifier, and then metrics का. So first step is this. You can insert commands as well, right? So wherever it is better, right? See, after few days you see into this IPVNB file, I'll not remember that what did I write, why did I write like this, right? So you, if you want, you can insert uh, comments like this, right? Wherever required, we have been doing that, right? So similarly, we will be loading the iris data set, right? So though we have three, more than two features, right? So we will be importing, we will be interested based on classification based on only uh, two features, right? That is why I'm putting is to two, right? So this I'll execute and then, right. So we will be taking only two classes. That's what we have been doing, right? I'll do that. Only we will consider two classes. And then what is the next step? Yes, your guessing is right. We are splitting the data into train test, right? So let me do that. So I'll write a command. I'll write a, right. So this is what I've been, I just copy pasted the same thing what we have done for logistic regression. Then we will be using linear SVM, right? So what is the kind of model that we are doing? Say, I know like in this data set, let me try with linear SVM. If it doesn't work out, then I'll think of kernel based SVM. Right. So kernel, what is the type of kernel that I'm giving? I'm giving a linear type of kernel. Okay. So let me train my SVM model. Okay. Then is the next step would be the visualization of a decision boundary. Right. So I'm just directly giving you the code. Okay, please follow changing these parameters. Right. So you can change the color, you can change the range. Right. You can change, you can try possibly all the things, whatever you are doing. Line width you can change, then colors you can change, right? So essentially what are we trying to do in step 5 is trying to draw the decision boundary to separate both the classes, right? So let's try. I'm giving a code here, right? So but you have to try with changing different things and check how is this your, what is the effect of each of the parameter on your um, decision boundary. Okay. Then finally, my result would be I'll be evaluating it and drawing the confusion matrix. Right? Can you see this wonderful decision boundary? I know that there is some kind of it is like looking like a, though support vectors are being identified with the circles, right? In the class, if you remember, like I had taken only one support vector on each of the side, or in the other problem numerical that we solved. So we had one support vector on positive class, other support vector on the other two support vectors on the negative class. But you can see now I have many support vectors being identified, right? So in this case, do the if I try to do the evaluation, right? And let me check, right? So almost I have got 100% everywhere, right? So this is how I do the support vector machine, right? So what are the take home message? Take home message is I've been doing this, right? And I have used kind of linear support vector in order to do this. Right. So the next part would be how do I change this? Right. So when I'm training it, so what is that part that I do is I'll make a small changes here. Okay. In step number 4, what I do is instead of this making a kernel as linear, okay, I'll be using non-linear kind of thing. Right. So, in case of a non-linear kernel, non-linear SVM, right? What we do is, if you remember in the step 4, we had written kernel is equal to linear, right? So, in case if my data is such a way that I will not be able to separate it by drawing a line, or I'll not be able to do it with the help of linear characteristics of a line, then in that case, I will define something called as RBF. RBF is radial basis function, right? So, which is nothing but in most of the cases, if I'm able to move my data into higher dimension space, it would be easy for me to separate it out. And hence, I'll be using a formula as shown here, right? So, where gamma is nothing but, right, in order to have a, if the gamma value is small, then that means, so I'll be able to have a smoother decision boundary. While if I keep this gamma value very large, right, so the influence would be narrow and it would be more complex, and decision boundary would not be smoother. Right. On the other hand, there is one more parameter called as C. Right. So C is nothing but the larger the value of C. That means so lower tolerance for misclassification. Right. It is kind of risk of overfitting. Then if I keep the value small, C, then I have a more tolerance. Okay. The decision boundary is simpler and risk of underfitting. So this is what about the RBF that we will be knowing. Right. Now, in the step 4, what I do is remaining everything, I'll keep it same. Only thing is in the step 4, instead of defining kernel is equal to linear, I'll define it as kernel is equal to, um, I'll define the kernel is equal to RBF. this is what I have. Now next I will insert the code wherein which I will train my SVM model with nonlinear with nonlinear kind of a kernel, right? So now you can see if you observe this previous one, there was a straight line, right? And now in this case, it is kernel based, right? You can see that nonlinearity is introduced. And similarly, you have one more data set. You can make, you can create your own data set, right? So you can create your own data set and implement SVM in that, right? So please try out. I'll show that in the next video, right? So this, we have covered both the things here, linear SVM as well as non-linear SVM in this video, right? So in the next video, we will try creating some small data set. So which we can import it from sklearn again, make moons, make circles kind of a data sets. That is simple 2D data set on which we will apply SVM. Okay. So in case if you have more doubts, okay, about SVM, please read theory and attend the theory classes so that you will understand it better. Okay. See you in the next video. Thank you.